Find the value of n so that this particular expression may be the geometric mean between a and b. So we have been given that this particular expression is the geometric mean of a and b, maybe actually. So we have to figure out the value of a and b basically. So how will we go over doing that? We have been given square root of ab, that is a geometric mean, right? Or let us write geometric mean is given to be a n plus 1 plus b n plus 1, this entire expression divided with a n plus b n. We know that geometric mean itself is square root of ab. So I'm going to rewrite, there are quite a few things. Geometric mean is ab, okay, which can be written as square root of a into square root of b, which in turn can be written as a to the power of half into b to the power of half. So therefore, end of it, what can we conclude? Well, a to the power of half into b to the power of half should be equal to a to the power of n plus 1 plus b to the power of n plus 1. See, the only way we will be able to solve this is if we happen to have a single term and we are able to compare the powers on both ends, right? If not, well, we can't do this. There's nothing that we know will help us to solve this. To achieve the sameness, the underlying principle over here is to get a single term. Okay, so the principle over here is get a single term. Or get terms wherein we have the same base on both ends. Same base on both ends. So either of this will help. Yeah. Okay. So what do we have over here? We have a denominator over here. So I'll transpose it over there. So e to the power of half into b to the power of half. Is multiplied with a to the power of n plus b to the power of n, which is equal to a to the power of n plus 1 plus b to the power of n plus 1. And now we have a to the power of square root of a square root of b into a. So that would be something like this. And we have the second term. Again, I'm just multiplying. I'm just using distributive property. Then we have a to the power of half into b to the power of n plus half, which is equal to a to the power of n plus 1 plus b to the power of n plus 1. Right? So can we do something? Oh yeah, before that, let me write the related formula. So we have used a to the power of n into a to the power of m, which is a to the power of n plus m. So with this formula, we are able to write this expression, this. Okay, now what can we do? So let's think about rearranging or think about it. So we have a to the power of n plus half and so on and so forth. Here too we have a to the power of n plus 1 and all of that, right? So let's arrange things which are at least a bit similar. That's the whole agenda, right? That's the whole principle. So to do that, let me get this term. Actually, this is smaller, right? In power, this is smaller. So let me take this across to the right hand side, while I'll keep a to the power of half into b to the power of n plus half, and I'm transposing this onto the LHS, right? And I'm transposing this onto the RHS. So a to the power of n plus 1 minus a to the power of n plus half. Right? Okay, this is where the tricky part comes into picture. How can I relate a b to the power of n plus half and b to the power of n plus 1? Think about it. It's not that hard, but yeah. How will we rewrite? See, anything to the power of n plus 1 can be written as n plus half. I'm writing half plus half as 0.5 easier. Can I do that? Because half plus half is 1. Is it not? So basically, I'm going to rewrite this particular expression as b to the power of n plus half minus b to the power of n plus half plus half. While on the RHS, we have a similar condition. Okay, I can do that. Is it not? And then I'm going to use this particular formula again, the other way around. So we have a to the power of n plus something. I can write it as a to the power of n into a to the power of that something. So in this case, I'm going to rewrite. So this is where people will get confused. So please see this carefully. A to the power of half into b to the power of n plus half minus b to the power of n plus half into b to the power of half. Again, I just made use of this particular formula, the other way around, right? Similarly, I'm going to rewrite the RHS n plus half into a to the power of half minus a to the power of n plus half. Now on the LHS, what is happening? I have b to the power of n plus half, that is common over here, and this is common over there. I think I didn't miss anything. I think I'm missing this over here. Oh, I missed one term altogether. So this would be b to the power of half, and I'm missing that. B to the power of half, b to the power of half. Yeah. Now, so I'm going to take common. So we have b to the power of n plus half on the left hand side, and this is a to the power of half minus b to the power of half, and this is equal to a to the power of n plus half into a to the power of half minus b to the power of half. So what is common? Clearly we have these two terms are the same, is it not? Here there's a single term, here is a single term, it's the same term, so I can cancel. All I have to do is b to the power of n plus half is equal to a to the power of n plus half. If I transpose it onto the left hand side, what will happen? Basically, I'm going to divide, right? I'm dividing both the sides with, again, I'm doing it slowly. You can skip quite a few steps, but I know many people find it difficult, so I'm doing it slowly. So this will be 1, and this is b by a whole to the power of n plus half. Agree? And 1 in turn can be written as b by a whole to the power of 0. Is it not? So basically, if I happen to compare the powers, because the bases are same, I can equate half to 0. So let me do that. Last step. N plus half is equal to 0. The reason being bases are same. And finally, we have n is equal to minus half. Right? So the possible value for n is minus half, And what else we have to find? That's it. Okay. Yeah. Again, watch the video slowly. It's all exponential algebraic scenario, so don't miss anything. Watch it carefully, work on your basics. If you find this difficult, then you should be working on math basics exponential topic.